The life cycle of a star takes place over millions, or even billions of years. Stars are the brightest objects in the night sky because of the vast amounts of light and heat given out by nuclear fusion reactions. All stars form in the same way, but the death stage of a star's life cycle depends on the size of the star. A star's life begins when a stellar nebulae begins to form. This is where clouds of hydrogen gas and dust are pulled together by gravity. Over time, the stellar nebulae begins to spiral and will eventually collapse and condense. As the stellar nebulae condenses, the center becomes denser and hotter. This is when the protostar is formed. The protostar continues to grow as it pulls in more gas and dust. The temperature also continues to increase, increasing the outward pressure. When the protostar reaches about 15 million degrees Celsius, it is hot enough for nuclear fusion to begin. The hydrogen atoms fuse together, forming helium, and releasing vast amounts of heat and light. This is the beginning of the star's main sequence. The star will spend most of its life like this. The size, luminosity and temperature will remain stable because the outward radiation pressure from nuclear fusion is equal to the inward acting gravitational forces. The death phase of a star will depend on its size. A star is classed as either a solar mass star, about the size of our Sun, or a high mass star, which is much more vast. High-mass stars have a shorter lifespan because the hydrogen fuel for nuclear fusion is depleted much more quickly. The first stage in the death phase of a solar mass star is the formation of a red giant. As the hydrogen fuel depletes, the star begins to collapse inwards. This causes the outer layers to expand and cool, forming the red giant. It continues to expand until it reaches a size that is hundreds of times larger than its original size. Planetary nebulae are formed when the outer layers of the red giant are ejected. When this happens, the core is now a white dwarf. The white dwarf is hot, dense, and about the size of Earth. Nuclear fusion reactions have stopped, and over billions of years, the core cools down. When cooling is complete, it becomes a black dwarf, emitting no light or heat. If the star is a high-mass star, the death phase is slightly different. As the main sequence comes to an end and the hydrogen fuel depletes, a red supergiant is formed. It expands to several hundred times the size of our Sun. It eventually collapses, and this collapse triggers a supernova explosion. This explosion releases vast amounts of energy and creates heavy elements that are scattered throughout the galaxy. It is the brightest object in the night sky. The core that remains after the supernova explosion will either be a neutron star or a black hole. A neutron star is an incredibly dense object. The most massive stars form black holes. This is a region where gravity is so strong that nothing, not even light, can escape. We can only infer their presence by the way in which they bend light passing close by.